fellow students and respected teachers. In today's video, we're going to be doing chapter number 1, book D1, primes, highest common factor and lowest common multiple. So let's get on with the video. In our previous video, we covered what prime numbers are and what composite numbers are. So in today's lecture, we're going to be covering what highest common factor and lowest common multiples are. So first of all, let's start with HCF, highest common factor. Now what is a factor? So we get our number, let's just say 18 and 30. We're supposed to find their factors. Now what are factors? Factors are numbers which when multiplied with another number give us this value. For example, we have 1 which when multiplied with 18 gives us 18. 2 into 9 equals 18. 3, 6 times 18. So we can say that the factors of 18 include 1, 2, 3, 6, 9, and 18. Moving on to 30. 1 into 30 equals to 30. 2 times 15, 30. 3 times 10, 30. 5 times 6 equal to 30. So we can write over here that we have the factors of 30 which are 1, 2, 3, 5, 6, 10, 15, and 30. So now that we've got this, we can say that we found the factors of these two numbers. Now, we got the factors, but we're supposed to find the HCF, the highest common factor. Now we're gonna find the common factors. So when we have to find the common factors, we have to see which ones are common. We have 1, we have 2, 3, 6, and that's it. So we can say that the HCF, the common factors, include 1, 2, 3, and 6. This is called the listing method. Now we have to see which one is the highest factor in this. So we're going to have to say that the highest factor is 6. So we can write that the HCF of 18 and 30 is 6. That's our answer. Okay, so let's see work example 10 on page number 16. They're asking us to find the HCF of 3 values, 40, 60, and 100. I'm going to apply method number 2 over here, how to find HCF of a value. We can use the method shown above, but as you can see, we have huge numbers like these. They might have many factors, so it might be troublesome to find whole factors. So we're going to apply method number 2 over here. Now what is method number 2? It is the same as prime factorization. We're going to use a prime number, let's just say 2, because these all are divisible by 2. 220 times 40, 230 times 60, and 250 times 100. Still divisible by 2, we're gonna again divide it by 2. 210 times 20, 15, and 25. Now these numbers cannot be divided by 2. So we're going to divide them by another prime number, which is 5. So we're gonna have to say 5 2s are 3, 5 3s are 15, and 5 5s are 25. Now these numbers cannot be divided further, so what we're going to do is we're going to take this side, we're going to leave this side, okay? We're going to take this side, we're going to write HCF, and we're going to take it as 2 into 2 into 5, which is 20. And that is our answer. We've got 20. Okay, now let's move on to LCM, lowest common multiple. Now, what is a multiple? Now, if we have to see what are the multiples of 2, we're gonna see the values which we get when reading its table. 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10, and so on. These values are the multiples of 2. So when we are going to see the lowest common multiple, we're going to write down the multiples of a number. Let's just say we have to write down the multiples of 6. So we're going to write down the multiples of 6, which is 6 itself. Then we have 6 ones are 6, 6 twos are 12, 6 threes are 18, and we have, after 18, we have 24, we have 30, 36, and then so on. Then we're going to write down the multiples of 10. Let's just write about 10. 10 itself, then we have 20, 30, 40, 50, 60, and so on. Okay, now that we've written the multiples, we're gonna have to find the common ones. Let's see which one are the common. Do we have 6 over here? No, we don't. We don't have a 10 over there also. But we do have a 30, which can be spotted right here, over here. Now, if you continue this, you will find 6, 10 times 60. So we're gonna have to do it over here as well. So now that we got two multiples, we're gonna find the LCM. Now, when finding the LCM, we have to use the listing method, and we have to see which ones. We have 30 and we have 60. Which one is a lower value? We have 30, which is the lowest common multiple. So we're gonna say that the LCM of 6 and 10 is 30, and that concludes our answer. Okay, so let's try worked example 11, which is asking us to find the lowest common multiple of 30 and 36. We've got two values over here, and we're going to try the second method, which is the method of prime factorization. So whenever we're doing that, we're going to have to prime factorize these both values. Let's see which number can divide 30 and 36. We have 2, because 2 15s are 30 and 18 goes under here. Then these numbers cannot be divided either by 5 or 2. We're going to divide them by 3. 3 5s are 15, 3 6 are 18. We're going to stop here because we cannot divide them further, and we're going to take these both values and we're going to take these both values. So whenever finding the LCM, you also take the remainder. We're going to write it as LCM of 30 and 36, which is equals to 2 into 30. And then we're going to add these two values. Multiply by 5, multiplied by 6. Okay, so we've got here. We're going to multiply this and we get our answer 180. And that's the LCM of 30 and 36. Okay, so let's try practice now 11 on page number 18, question number 3. The question number 3 is a little bit tricky. It's asking us to find the smallest value of n such that the LCM of n and 6 is 24. So we basically are given the value of LCM, which is 24, and we are supposed to find the number, the second value, which is n. So first of all, in order to do this question, we have to write down the factors of 24, which is 1, 2, 3, 4, 6, 8, 12, and 24. Now that we've got all the factors, we're going to find multiples of each individual number, like this. So firstly, let's write down the multiples of 1. We have 1, 2, 3, 4, 5, 6, 7, 8, and so on. Let's write down the multiples for 2. We have 2, 4, 6, 8, 10, 12, 14, and so on. Then let's write down the multiples of 3. 3, 6, 9, 12, 15, 18, 21, and so on. Let's write down the multiples of 4. 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 4 6s are 24, and so on. Let's write for 6. 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are, we have 24, and then we have 30, 36, and so on. Then is the turn of multiples of 8. We're going to write down the multiples of 8. 8 1s are 8, 8 2s are 16, 8 3s are 24, and so on. Then we have to write down the multiples for 12, 12, 24, then we have 36, 48, and so on. Then let's write down the multiples for 24, which we have 24, and we have 48, we have 72, and so on. Now we have to keep this in mind that we are finding the lowest common multiple. Now in the question we know the second value, which is 6, right over here. So what are we going to do? We're going to take this box of 6 and compare it with the others and find the common multiples. So let's just start with 1. So what's the common one? First common factor, the least common factor. There is 6 common over here, but we have to find the least common multiple, which should be 24. So it automatically cancels for 1. 1 is not equals to n. Then let's try with 2. We have 6. Again, 6 is the least common multiple over here, so it's not possible. Let's try with 3. For 3, we also have 6 again, right over here, sharing with the multiple of 6. So we cannot say this is the one. Then let's just check with 4. We have 4, 8, 12. Now 12 is repeated right over here. It's the least common multiple, so we cannot use 12. Then let's try with 24. There is no other number other than 24. We can say 24 is repeated. So we can say, yes, this might be the answer because the least common multiple we have is 24. So this might be the answer. Let's check with 12. We have 12 here again, so we cannot say this is possible. Let's check with 8 now. Now while checking with 8, we have to see 24, which is the least common multiple. So we might say that 8 or 24 might be answered. So n is either equals to 8 or n is either equal to 24. But they asked us to find the smallest value of n. Now the smaller one over here is 8. So we are going to say that n is equals to 8, and that is our answer. Moving on, we have real life applications of HCF and LCM. So we can apply both of these methods in our real life situations, such as we have worked example 13 over here, which includes LCM. It says that there are 3 lights on a light ship which flash at regular intervals. The first light flashes every 18 seconds, the second one flashes every 30 seconds, and the third one flashes every 40 seconds. So they all flash together at 10 p.m. and we have to tell at what time will they flash together next. Okay. So first of all, we're going to have to use 3 values and we have to prime factorize them. We're going to take the LCM. So we have, just like over here, 2 9s are 18, 2 15s are 30, 2 20s are 40. Then we have 5, and we write the 9 as it is, 5 3s are 15, and 5 4s are 20. Then we use 3 3s are 9, 3 1s are 3, and we move the 4 downwards as it is. We again use 3 to turn this 3 into 1, and then we use 2 to divide 4 with 2, and then again 2 to turn this 1 1 2 into 1 1 1. We have got this whole side right over here. So what are we gonna do? We're gonna write this down that the LCM is 2 into 5 into 3 into 3 into 2 into 2. We've got this. We're gonna solve this whole and we get 360 seconds. We've got 360 seconds. Now we can't just add 360 seconds into 10 p.m. So what we're gonna do, we're gonna turn this into minutes. Now in order to convert it, we have to divide 360 by 60 and we get 6 minutes. Our answer is not complete here. What we're gonna do is we're gonna take this time and add it into the initial time. So we're gonna have to do it 10 plus 0, 0, 0, 0, 6. What do we get? We get 10, 6 p.m. So this is our answer. The 3 lights will next flash together at 10, 6 p.m. Okay, so let's do exercise 1B, which is on page number 21. We can see question number 1, which is asking us to find the highest common factor of each of the following sets of number. Firstly, let's start with the D part, which is a little bit tricky. It says 77, 91 and 143. Okay, so let's try them. We have 77, 91 and 143. Now you can see if they are divisible by the prime factors. We have 2. No, these are not divisible by 2 because you can only divide even numbers. Then let's see 3. We cannot divide 77 by 3 and neither can we do the same with like 91 or 143. What about 5? No, there is no 0 or 5 in 3 of these numbers. Then what about 7? Yes, 77 can be divided by 7, which can be 7 11s are 77. And what about 91? Can 91 be divided by 7? Yes, it can be with 13. But what about 143? No, it will not divide 143. Then let's move on to the next prime number which we have, which is 11. 11 can divide 77, 11 can divide 143, but 11 cannot divide 91. Then let's try 13. 13 cannot divide 77, but it can divide 91 and 143. But we need a number which can divide all of these. So you can say that no number is dividing it. Then what are we gonna do? We're gonna just do 1 and then write them back over here, because 177s are 177s are 77, 191s are 91 and 143s are 143. So we're just gonna say that the LCM of this is, we can say 1. That's our answer. Simple. Okay, now let's see the C part of this question. The C part says 15, 60 and 75. Let's try this one over here. We're going to write it in the prime factorization method. 15, 60 and 75. 5 3s are 15, 5 12s are 60, and for 75 we have 5 15s are 75. This can be divided by 3, 3 1s are 3, 3 4s are 12 and 3 5s are 15. Now we're gonna take this side because this cannot be divided further. We're just gonna leave it here and we're gonna write LCM, which is equals to 5 into 3, which is equals to 15, and that is our answer. Okay, so let's go on to the second question, which asks us to find the lowest common multiple of each of the following sets of numbers. The A part is 24 and 30. So using the prime factorization method here, I have found the answer. 2 12s are 24, 2 15s are 30, 3 4s are 12 and 3 5s are 15. Now we're going to use this side and this side because this is the LCM. In HCF we don't use the remainders, but in LCM we do. So we're gonna write here LCM, which is 2 into 3 into 4 into 5, which is equal to 2 3s are 6 multiplied by 20 equals to 4 5s are 20. So this will be equals to 120, and that is our answer for the first part. Okay, so let's move on to the B part. We have the B part here is 42 and 462. 42 and 462. Again, we're gonna use the prime factorization method. Make a table. 42 and 462. 2 2s are 4, 21, and for this 2 2s are 4, 2 3s are 6, and 2 1, like that. We've got that. Now we're gonna divide this by 3. 3 7s are 21, and then for 231 we have 3 77s are 231. We're gonna use 7 7 1 and 11. Then we're gonna use 11 and write it like this. We're gonna use this side. We're going to write LCM equals to 2 into 3 into 7 into 11, which is equals to 2 3s are 6 multiplied by 77, and 77 multiplied by 6 is equals to 462, which is our least common multiple of this B part. Question number 3. Find the largest whole number which is a factor of both 42 and 98. We have to find the largest whole number. So this is the same. We just have to find the HCF of 42 and 98. Nothing new. They just changed the words only to trick the student. So we're going to prime factorize it. 42 and 98. We'll do this by 2 first. 21 and 49. Then we have to divide that by 7, which is equals to 3 and 7. We take this side, and we do not take this side, sorry, and we take this side. We do not take this side. We do 2 into 7, which is equals to 14, and that concludes our answer. Let's try the question number 4. The numbers 792 and 990 written as the products of the prime factors are 792 equals to 2 cube into 3 2 cube into 3 square multiplied by 11, and 990 equals to 2 into 3 square into 5 into 11. Hence, find the greatest whole number that will divide both 792 and 990 exactly. So we do not need to prime factorize it. They have already given us the value. I will write it down. 792, which is equals to 2 cube multiplied by 3 square multiplied by 11. And then we have for 990, which is 2 into 3 square into 5 into 11. Now we just have to see the common things we can spot. We can also write this as, you can say, 2 into 2 into 2 into 3 into 3 into 11. Just changing the powers into the numbers. Then also the same thing over here. We can write it as 2 into 3 into 3 into 5 into 11. Now we can see the common things. 11 over here is common. Then we have a 3 common over here, a 3 common over here, and a 2 common over here. So we can write this that the HCF of this is 2 into 3 into 3 into 11, which is equals to 198, and that is our answer. Okay, so in question number 7, they're saying Hujian needs to pack 171 pens, 63 pencils and 27 erasers into identical gift bags so that each item is equally distributed among the gift bags. Let me write down the amount. It is 171 pens and we have 63 pencils and then we have 27 erasers like this. So now that we've got this, they have the condition that he has to pack each item equally distributed among the identical gift bags. So the first part is asking us to find the largest number of gift bags that can be packed. Now in order to find the largest number of gift bags that can be packed, we can simply find the HCF of these three values. So let's see what we get. We get 171, 63, and then we get 27. Let's see what divides these numbers. I'll get a calculator right over here in order to do fastly. And we have 171. Let's see if this can be divided by 7. No, let's try if this can be divided by 3. It can be divided by 3. So let's divide this whole with 3. 3 57s are 171. 3 21s are and 3 9s are. Okay, so now that we've got this, let's see if we can divide this further. Can 57 be divided by 3? Yes, it can. It can be divided with 19. 3 19s are 57. 3 7s are 21. 3 3s are 9. Now this further cannot be divided, so we're just going to leave it here. And as we're finding the HCF, we're going to take only this side. And we will get our answer 3 into 3, which is equals to 9. So this means Hujian can only pack the maximum number of 9 bags equally with the items he has. Now the second part is asking us to find the number of each item in a gift bag. That is very simple actually. You can see this value right over here and you can implement it on that. He will have 19 pens left, 19 pens in each bag, and then 17 pencils in each bag and 3 erasers. So this is what each bag will have. And that's our answer of the second part. 19, 7 and 3. That's it for today's video. Make sure to like and subscribe. Turn on the notification button if you want to get notified for new uploads. And I'll see you guys next time. Goodbye.